All right, so it's Monday evening. Actually, the clock tells you that. Just give an update on the GPS Disciplined Oscillator. I finished it, finished the soldering part today, worked on it Saturday. On Saturday, I got the components soldered in, ran the power. On Sunday, I did the control panel and I did the high frequency section, and then today I finished up with the counter and the phase comparator. It had some issues, some shorts, miswirings here or there, but overall it went fairly smoothly. I did actually have on Saturday a power short someplace, and I thought I would have to pull up a lot of the power wiring, but then I remembered I have a handy this thing is it's a infrared camera, and so with it you can see where the hot spots are. There's the delay line actually is very, very hot, and so is the oven oscillator, of course. But with using this, you can look at I could see the hot spot where the short was occurring, so it was actually really easy to find and take care of. So it's a handy piece of equipment. And then this is the buffer to drive the signal out the front panel or the rear panel through the BNC. And I was using one of these to do both the 10 megahertz and the synthesized frequency. And as it turns out, that's actually not very good. There was, I wouldn't call it crosstalk in the chip, but when you had both outputs enabled, there was some amplitude noise, and so I just added a second separate chip, and so that went fairly smoothly. And then here it works. It's clicking away. I'm at 23 seconds between clock slips, and I forget what that is. That's 10 parts per billion, maybe. I need to remember what the conversion factor is. But all the buttons work. I can change the frequency offset with the buttons, and then I can use this to control what the synthesizer frequency is, and I can set it. So it all works out, and these are the output enables for the outputs in the back. It all works really well. I had one hiccup just now with the GPS. It was taking forever to sync, but then I forgot that on that particular PCB I did not put in the right size battery, so I had to find a battery. Some of the things that I learned doing the project, not really on the solder thing, but when I was working on the breadboard version, you always need wires that are just the right length to fold nicely and skip over, and it's always tricky measuring that. So I made these little templates. This one goes 4 holes over, and so when you want the wire, you just hold up that to the wire you want, cut it, and there you go. I would usually make a couple that were the right length, and I forget what size they were for, so I made these little templates. The other thing that I'm going to do, these are the jumpers that go to the front panel switches, and I'm going to use, I wanted to use these quick connect connectors, and they have different sizes depending on how many pins you want to do, and those get really fiddly because you have to use the crimp tool, and you have to crimp these on, and it's hard. Which way does it go holding the wire? I never have any good luck using this tool, but then I was poking around, and it turns out you can buy these terminated ribbon cables that either have male or female ends to them. And so what I'm going to do is here's one that's 4 wide. These crimp-on ends are the exact same as is used by those other connectors, and so with the inappropriate tool, you can just break that plastic, and you can get access to the connector and that if you want to use this, these wires just slide in, and there's no soldering required. And so I'm going to use this to make all the connectors, and it's going like that, and it plugs in, and then I'll when I decide to determine the right length, I can just cut this wire off and solder it to the switch. So it's going to be a really easy way to make the connectors for the switches. Trying to think what else. Oh yes, right. This is the feed through. It's going to be in the back for the programming the Arduino. This goes to that right angle connector, and then there'll be a USB connector in the back on the back panel, and then this is going to be the GPS attachment poking through the back panel as well. So good progress. My eyes were being zapped out looking through the microscope and soldering, but I paced myself and getting good results. Oh, the other thing I noticed is, compared to the breadboard, the power distribution is a lot more fixed. So when you went from breadboard to breadboard to breadboard, you were just going through lots of breadboard connectors, and actually there was a big voltage drop. So I had to have this at 5.3 to get 5 volts on the ends that were furthest away from the power input. Here it says 5.1, and I'm getting 5 volts basically all over the board. I think the main part of the loss is in this wire over here. So that's been good, good solid. And then when I look at the signals with the oscilloscope, there's still the ringing from the bad ground discipline, or probe grounding discipline, but in terms of the noise, it's very well controlled. So I'm happy about that as well. So this should go pretty smoothly. The fab for the front and rear panel is due back a week from tomorrow, so hopefully in a week or so I'll assemble it and do the final video. This is the only opportunity probably to show this board, because everything's going to be put together on the next video. So that's what's happening. Again, happy with the results. The board went together fairly well. I'm glad I have the control panel there to test things out, and then I have these nice jumpers to make it easy to take in and out of the chassis. So hopefully a week from tomorrow or maybe Wednesday, I'll have the final video. All right, thanks for watching.